Divided.
Is Caitlin okay? Did she get, you don't know?
We have to practice this one too. That's a lot of math. I don't have that many power.
All right, so I think we started this one yesterday and you guys unanimously voted to save it for today. But we're not getting off the hook because we're going to do it. Okay, so we have 3 partial fractions in this case. Let's not get too overwhelmed because it's still going to act the same way. Did we discuss yesterday where like the A, B's, and C's came from? Like how we had to multiply opposite denominators? Okay, let's go ahead and pick some strategic x values, bless you, that would cancel out an A, a B, or a C perhaps. Two. Okay, so let's see. If we were to plug in 2, that would cancel out A because it has a factor of x minus 2 attached to it. And it would also cancel out B. So that's nice. If we plug in 2, we're going to be solving for C. So let's go ahead and see what happens. If you plug in 2 for all the x's, 2 squared is 4 times 16 plus 26 minus 12. I think that's 30. And we already said plugging in 2 would cancel out A and B. If we plug in 2 for the x's with the C term, we would have 2 times 5. So that would give us a 10C that's left. So solving for C looks like we get 3. Can we pick another strategic x value? 0. Okay, so that would get rid of B and C because it has those individual x's. If we plug in 0 on the left-hand side, we'll get negative 12. Plug in 0 for the A term, we'll have 3 times negative 2, which is a negative 6. So it looks like A is 2. And what about our last x value? Negative 3, yep. Okay, so negative 3 on the left-hand side. 4 times 9 minus 39 minus 12. I think that's negative 15. And plugging in negative 3 would cancel out A and C, so we're left with B. Negative 3 times a negative 5 would leave us with 15B. So it looks like B is negative 1. All right, so if we were to substitute in 2 for A, negative 1 for B, and 3 for C, can we figure out our antiderivative? Yep, maybe using our little shortcut, we'd have 2 natural log of x minus natural log of x plus 3 plus 3 natural log of x minus 2 plus c. Okay. None of those factors in the denominator had a coefficient on the x, so we don't have to worry about dividing any of those 2 negative 1s or 3s by something. I think we saw that yesterday. And also, none of the coefficients out front have the same number value, so we cannot use a property of logs to combine them somehow. So this is how we have no choice but to leave it. Do you see how 3s aren't too bad? It's the same process, just with an extra one to take into account. All right, let's check out 7. I think this is our last one. Can we look at this one a little bit more closely? Do you notice anything about this fraction that's a little different than the other ones? Yeah.
Only two long division
Why?
because there's a higher power that's on the top and bottom.
All right, so this is technically an improper fraction. The degree of the top is greater than the degree of the bottom. So we're going to do long division to turn it into essentially a mixed number fraction. Okay, not have it improper anymore. So let's go ahead and set up our division. We have 4x cubed. We're missing an x squared term. So we have to put in that 0 placeholder. And in the divisor, we're missing the constant term on the end, so we'll have to put on that 0 placeholder as well. Do you remember long division? I know we went through it a couple weeks ago. So x squared times what would give us 4x cubed? We would need a 4x. We can multiply that 4x over to the divisor. From there we can subtract. First terms cancel. 0 minus negative 8 changes to positive. Negative 3 minus 0 stays in negative 3x. And we can bring down the next term or the rest of the terms, whatever you feel comfortable with. All right, so what do we have to multiply x squared by to get an 8x squared? Be 8. Multiply that over to your divisor and subtract. First terms cancel. Negative 3 minus negative 16 will change to a plus 16. And 5 minus 0, we're left with 5. All right, so this improper fraction that we started with, how can we rewrite it based off of that division? Let's see, we have, if we were to label the different parts, we have quotient, remainder, dividend, and divisor, different parts of division. Can we combine that long division process to write what the mixed fraction or mixed number would look like? Do we need to do a number example to kind of make the connection? What do you think? Yeah.
It would be 2x squared plus 8x and then plus 13x plus 5 over x squared.
What was your first part?
What you got on the quotient?
Did you factor it? You said 2 times something? Or did I miss that? You don't remember? Okay, so you're right. We're going to take the quotient, 4x plus 8. So that's how many whole parts go in. And we're going to add the remainder over the divisor. All right, if we thought of a number example, for instance, if we did 11 divided by, we'll say 5, okay? 5 goes into 11 2 whole times, so that's your quotient. Okay, 5 goes into 11 2 whole times, so that would give you 10, and you have 1 left over out of the 5 that you were originally dividing. So I know we don't normally write 2 plus 1/5, we just say 2 and 1/5, okay, but we need the addition in this case because we're working with polynomials instead of just numbers. Okay, so this original fraction after long division can be rewritten as this mixed fraction or mixed number if you want to think about it that way. Let's go ahead and see if we can work backwards from what we have now. So backwards from 4x, we'd have a 2x squared. Backwards from 8, antiderivative, we would have 8x. And how might you want to work backwards from the fraction? Think about your techniques. Can we do reverse power rule? Can we do U sub? Can we do partial fractions? Can we do integration by parts? We have these all these different options now. Let's check this out. Okay, let's check out U sub. What do you want to let U be? The whole bottom. Okay, so then the derivative would be 2x minus 2. Okay. Do you notice how when solving for du, this numerator would not cancel out with what's left there? So we would still have x's left. Okay. So U substitution is a valiant effort, valiant try, but it's not going to work out as nice. No, don't get frustrated, okay? You always try something. If it doesn't work, go on to something else, okay? It might be the story of your life, but we're not quitters, okay? You just keep rolling, okay? So U substitution's not going to work, at least as nicely as we would want it to, okay? We have a fraction, so reverse power rule, we're not really working with x's to powers. Anything else you want to try? By parts, maybe? Okay, that involves multiplying two things together. We're dividing the two things together, yeah?
We're going to have to do partial fractions as well.
Partial fractions again. Well, we actually haven't done it yet, okay? We just did long division, right? We haven't done partial fractions. Now, partial fractions is dependent upon being able to factor the denominator. Can you factor the denominator? Yes. Okay, so let's go ahead and do that. So, what would our partial fractions look like? If we factored the denominator, we'd have a factor of x and then a factor of x minus 2. And we'll throw in those temporary numerators. All right, so if we were to add the partial fractions together, a would have to be multiplied by x minus 2, b would have to be multiplied by x, and those numerators should, when added together, should equal the original numerator from your integral. Because remember, this is your resulting fraction. This is the answer you would get after you do that addition. So strategic x values. Got 2 and 0. So if we plug in 2, 26 plus 5, we'd have 31. And then a 2b. So b looks like 31 halves. If we plug in 0, we'll have 5 equals negative 2a. So a is negative 5 halves. All right, so if you thought about putting those in for your temporary numerators, okay, in your integral, maybe we can go ahead and write our antiderivative. We had the 2x squared plus the 8x from the quotient part. We were able to easily work backwards from there. And then the partial fraction pieces, looks like we'll have a minus 5 halves, natural log of x, plus a 31 halves, natural log of x minus 2. plus C. All right, so that one was a little special because it was an improper fraction. The degree of the top was higher than the bottom. So whenever that happens, just be aware that you'll have to do long division. Okay, change it to a mixed whole number or a mixed fraction. Okay? Pretty short section. Do you guys think you're doing okay? Nothing new, really? Just more practice, okay? I'll let you know who your partners are for tomorrow in a little bit. Do you guys want to start working on some of the homework problems? Okay? Nothing too fancy, just extra practice.